Okay, good morning and happy Tuesday. It is July 18th, and I'm planning on doing the code daily challenge for today. So here's the 18th LRU cache. I missed yesterday. What was I doing yesterday? Oh yeah, I did the contest virtually. Okay, but anyhow, LRU cache today. It's 9:11 in the AM. Oops. 9:11 AM. Okay, let's try to shine. Here we go. LRU cache. All right, okay, so it's a map, get put, capacity, and I picked the least recently used. Okay. All right, I'm pretty sure I saw this before. And yeah, I saw this about 3 years ago. And before that, about 3 years ago, like 6 years ago. Okay, cool. Well, might as well solve it this year. It's every 3 years I'll solve this one. Hit thumbs up, it's cool. All right, so anyhow, the game plan is an internal structure will be a map. It is an associative array. Associative array. Right, so it associates a key with each value. And then the key question we ask ourselves then is how to evict the oldest, right? That is the least recently used view, right? And this, I think we can just use like a queue, maybe just whenever, oops, we get or put a key, push it onto a queue. Then what about duplicates, right? So if you get something more than once, and it gets the head queue, it might still be within the capacity. So we use a counter too, counter as well. To actually perform evictions, right? That count 0. Okay, so that sounds good. Let's do this self.count, oops, count, counter, and then self.val will be a value map, a key value map. Okay, let's call this thing key value, just call it X. Okay, so get return self dot value k. What if it doesn't exist there? If it doesn't exist, okay. If k and self dot val, otherwise -1. Right, we can just rewrite this as k equals lambda self k. And then let's just grab this. Pretty sure that works. Okay, and then self value get. Oh wait, hold on. Actually, I can't do this yet. This doesn't work because we have to also have to update the counter, right? And then we need a queue, right? So it would just be a deck. Okay, so maybe some private function that we can call. Let's do this. Get put and then def. We'll call this guy evict or update. Yeah, just perform some updates. Update, and then do you want to give it K? I suppose we can give it K, right? Yeah. Okay, so whenever we do a get or a put, well, I'll update that key regardless of the value. Yeah, I think so. All right, so self.q append K while self dot value, the length exceeds the capacity. I'll just say it's our threshold. Oops, self dot t equals t. There's our threshold. Well, it exceeds our threshold. Oops. Okay, then update. It doesn't return anything. We can reuse k here. Key will be q dot pop left. If, let's see, so self dot count, so k minus equals 1, and then if self dot count, so k is 0, right, then we actually move the key, right? We perform the eviction, delete self value. Okay. So until we're back to the threshold. That is our capacity. Okay, so I think that works, right? So yeah, append it to the queue, pop the older ones from the queue. It is going to be linear though, right? Every single thing is pushed on the queue. We have a count. So Q is our historical breadcrumbs, right? So we pop them left, push to the right. Decrement the count. When we increment the count, when do we increment the count? We increment the count here. Self dot counts, okay. It's incremented by 1. So there's our counter. When we do update, try to get or put. Push the key onto the queue, increment the count of the key by 1, and then as long as our capacity of keys within the LRU cache exceeds the threshold of our capacity T, we pop in historical order, first in, first out, all the keys, decrement the counts, and then delete it from the values when the count reaches 0. Okay, I mean, that seems legit, right? Okay, so it's 9:19. It's like 8 minutes or so. Okay, so let's see. Let's run it and see what happens on the example input. Oh, self-sub, oops, okay, equals x. Okay. It is not defined. Oops, needs self. Update to kind of like a private function, I suppose, right? Okay, let's see what happens. Well, syntax error q, oops, it should be self.q. Self is very verbose, having to write self everywhere. That's one of, I think, Python's major downsides. Oh, what happened here? So it's trying to turn 2. 3 is not there. 2 should have been evicted, right? So you push 1, push 2, push 3, and evict 2. Let's just do some prints here. Update K here. U A is times K. And C is our threshold. It's the length. So, use self.val.keys. I wonder if that's right or not. Just length of self.val is fine. Yeah, let's just, before we try to remediate this, let's try to actually better understand it real quick. Okay, 8 minutes for incorrect implementation, which does not pass example one. Oops. Example one input test case, right? Yeah. Just get to that first part where we do the first eviction at 3, right? So remove those. Was it 5? Last 5. It's 5. Okay, so this should be enough to evict 2. All right, push 1, push 2, push 3. Since we get 1, it should not be evicted. Right, its reference count should not be 1. Of that count. Wait a sec. Okay. Oh, okay. So it didn't get to the point where it actually causes a failure, which is when we get to, and this is where it fails. So it should return -1, but it's actually returning 2, right? It's not actually properly getting evicted. 3 does exceed 2. Okay, so it should pop it. Get push. Let the count of 1 should be 2. Okay. Q. What the? Oh, okay, I need to see what's going on with the Q. Oh, okay. Okay. Is okay. No. Okay, and then let's do this. Okay. So pop 1 and count of 1 is 1. Pop 2. Count of 2 is count of 2, 2. Oh, get increments it. Okay, so oops, all right, so hold on. This is the result. Yes, okay, the result equals this. So yeah, if k is not in self.value, return -1. Otherwise, we update k and then return the value of k. Okay. So Git was having a bug, right? One. Okay, so that is right. But no, evicting one is not right. Hold on. Count to two is one. How is the count to two one? What the heck? Put one, put two, hit one, put three. Pop one. Count of one is one. When I pop two, count of two should be zero. And when we put three, put three, that's when we should. At this point is when we should pop off two, like the one and the two. Right. The heck? Popped one and counted one is one. That's fine. Counted two should not be one. And so now that keys length is the self now keys. What's it two? You can see it's clearly three here. Three. You have one, two, and three, which are all put. Self value. The heck? Oops, hold on. Oh, it's already printed there. Just print the keys. One and two. Why is three not there? Update K is three. Put. Oh, I see. Okay. All right. And return the value. Okay. Oops. Little mistakes make big outcomes sometimes. Okay, so anyhow, let's just comment these out here real quick. Yeah, a lot of times, yeah, going fast ends up end up going slower, right? So people fast is slow and slow is fast, and I am part of people. I keep having to remind myself that even though I'm trying to go faster, to be a contestant in lead code contest, It's a paradox, I suppose. Yeah, okay. So anyhow, it's 11 or 9:31. 9:31. 9:31 in the AM. So that took like 20 minutes. I didn't actually hit the submit button, so I don't count that as a bug, but I didn't have the right implementation. So I spent from 9:19 to 9:31, basically this whole time debugging. This is like 12 minutes, 12 minutes for debugging. Yeah, I spend a lot of time make some simple mistake like that. And basically I had these two lines inverted. This guy was before that guy. It needs to be like this. And I also did the same thing for the get. Okay. Little subtle things. It's kind of tricky. But anyhow, I'll look at previous solutions and then I'll do this in Kotlin and Rust. Let's see. This is back in 2020 when I was doing JavaScript and C++. What is this? So then so using a queue. So it is O of N key. Short and sweet. I don't know. This doesn't seem like a very good solution, right? So do a whole linear scan, an entire linear scan. Yeah, each of these is O of N, so that's kind of crappy, right? This one having a queue and a counter. It does update, but it only updates when it needs to based on the capacity here. It doesn't do a linear scan every single time, right? Those are really extremely inefficient. And it is concise though, and this is decent too. So use a queue and a counter, and this is our value. Yeah, it seems okay. Let's see what other folks came up with too. Let's look at the. I'm gonna have to subscribe for that. All right, double linked list. Holy cow! This guy's really getting into some low-level detail stuff here. Off the tab. Count. Okay. Yeah. Mm. Oh, interesting. I see. Oh, okay. Yeah, that is a good idea. Go to the front of the queue. Huh. Okay. Yeah, that works. Suppose we can post remove node and node a new node. There's no, you can't get it. You know, this is a pretty good solution. Yeah, that's cool. We'll put that guy. Double linked list. Okay. same kind of thing. This is very verbose. Found it. It's a pretty decent solution though too. Makes sense. Map.find. If it's an unordered map and we're invoking find on it though, that's a linear operation. Right? So it'd make more sense for this to be an ordered map rather than an unordered map. So we have logarithmic indels, right? Find is linear in an unordered map, isn't it? All right, no. Find is not linear. Find is O of one, isn't it? Yeah, it's O of one. Find is O of one. Okay, so what am I talking about? List of pairs of iterators. Let me see. It's verbose, but it is a decent solution too. Man, my code is slow. Takes care of everything, huh? Okay, either you implement the double linked list on your own, linked hash map. Yeah, that's awesome. It's cool to know. Learn something new. Okay, see what I got. Same thing. Okay. Look at a couple more of these things, and then okay, I get it right. Using the doubly linked list, we can implement our queue in a way that we can keep track of an iterator to each element, pop it out, push it back to the front. Yeah, that makes sense. Good solution. Yeah, that's cool. Ooh, I like that touch. Yeah, that's cool. Yeah, yeah, I like that. It's good. Yeah, it for iterator. That's awesome. That concept of touching it. For dictionary. Logarithmic, right? So good solution. it's a decent solution. Kind of meh. So let me go to my previous solution. I'll just update it. This is kind of junk solution. A few solutions. 1, 3. Okay, so note to self, use a doubly linked list next time. Okay, you just pop off. It's in the list of history, historic breadcrumbs, and push it back to the front. Okay. And then evict the back. Yeah, have update where the other dude is like touch it. Kind of a similar thing. Yeah. This is a pretty simple solution. We use Q to store historical. Like I said, there's historical breadcrumbs, right? For each key, we get the shares. Oops. Cache counter for whenever we get visible, which in the date. Okay, it is push K onto the queue. Increment out. Okay. And then perform reductions in reverse, or I guess in historical order, the queue, while the threshold T for the LRU cache capacity is exceeded. It sounds good. It's a decent solution. It's not the best. The other ones I'd say are better. So I don't know why folks have voted this one. It really wasn't that great a solution for sure before when it was a linear solution. So it's a little bit better. They still go through them one by one. So if there's a whole bunch of gets, then the queue is just gonna be like totally flooded. So yeah, it's not that great. But then I'd say that a lot of the most upvoted solutions are not that great as well. Okie dokie. Good geometry.